We spend a lot of time worrying about how the world will end. We worry about asteroid impacts. We worry about nuclear war. We worry about the death of the sun. But these are small problems. They only affect Earth. There is a theory in modern physics that suggests the entire universe, every star, every galaxy, and the laws of physics themselves is waiting to die. Imagine a ball sitting at the bottom of a valley. It is stable. If you kick it, it rolls back down. Now imagine a ball sitting in a small dip halfway down a mountain. It looks stable, it stays put. But if you nudge it just enough, it will roll over the edge and fall all the way to the bottom. Physics suggests that our universe is not at the bottom of the valley. We are the ball on the ledge, and the edge is closer than we think. To understand this threat, we must understand the foundation of reality. The universe is filled with invisible energy fields. The most important one for this story is the Higgs field. Think of the Higgs field as a cosmic ocean that fills every inch of space. As particles move through this ocean, they experience drag. This drag is what gives them mass. Without the Higgs field, electrons would have no mass, atoms could not hold together, and you would not exist. The value or the strength of this field is what determines the laws of physics as we know them. In quantum physics, we use the word vacuum to describe the empty state of these fields. It doesn't mean empty space, it means the state of lowest possible energy. If the Higgs field is in its absolute lowest energy state, the bottom of the mountain, we call it a true vacuum. This is perfectly stable. However, if the field is stuck in a local dip, a ledge halfway up the mountain, we call it a false vacuum. In a false vacuum, the universe has potential energy that it wants to release. It is metastable. It is like a dam holding back a massive reservoir of water. It looks solid, but there is immense pressure waiting to burst through. For decades, this was just a scary math problem. Then in 2012, we turned on the Large Hadron Collider at CERN. We found the Higgs Boson, the particle that proves the field exists. This was a triumph for science, but it came with a warning. We measured the mass of the Higgs boson to be approximately 125 giga-electron-volts GeV. We plugged this number into our equations to test the stability of the universe. If the mass had been lighter, we would be safe. If it had been heavier, we would be unstable. But at 125 the universe sits right on the razor's edge. The data suggests that we are in fact living in a false vacuum. So how does the end begin? It doesn't require a bomb or a massive collision. It requires a quirk of quantum mechanics called quantum tunneling. In the quantum world, particles can pass through barriers. At any moment, a tiny patch of the Higgs field anywhere in the universe could spontaneously tunnel through the energy barrier and drop to the lower true vacuum state. This is called a nucleation event. It is a spark. Once that point drops, it releases energy. That energy pushes the surrounding space over the edge. A bubble of true vacuum forms, and this bubble begins to expand. Once the nucleation event happens, the reaction becomes self-sustaining. The point of space that dropped to the true vacuum releases a massive amount of potential energy. This energy pushes the space next to it over the edge. Like a domino effect, the collapse spreads outward in all directions. It creates a sphere, a bubble of true vacuum. This isn't like a chemical explosion that fizzles out over distance. Because the vacuum of space itself is the fuel, the bubble never runs out of energy. It keeps growing, feeding on the instability of the universe, expanding forever until it runs out of space to consume. The scariest part isn't the destruction, it is the transformation. Inside the bubble, the Higgs field has settled into a new lower value. Because the Higgs field controls mass, the fundamental constants of nature change instantly. Electrons might suddenly become heavier than protons. The forces that hold atomic nuclei together might vanish. Chemistry becomes impossible. Matter as we know it cannot exist inside the bubble. Everything the bubble touches, stars, planets, doesn't just burn. It dissolves into a chaotic soup of unrecognizable particles. The bubble effectively deletes the laws of physics and installs a new operating system that is incompatible with life. The boundary of this bubble is a region of unimaginable violence. We call it the domain wall. All the potential energy released by the collapsing vacuum is concentrated in this thin shell. It is a wall of pure energy sweeping through the cosmos. Anything it hits is incinerated instantly before it can even be dissolved by the new physics inside. It is the ultimate eraser. If a star explodes, you see the light before the shockwave hits you. You get a warning. Vacuum decay offers no warning. The bubble expands at the speed of light. This means the image of the bubble moves at the same speed as the bubble itself. No signal can outrun it. If a bubble were heading toward Earth right now, even if it was only 1 mile away, the sky would look perfectly normal. You would look up at the stars completely unaware that the end of the universe was milliseconds away. You cannot see it coming. This speed has a merciful side effect. The human brain takes milliseconds to process visual information and register pain, but the collapse happens faster than your neurons can fire. If vacuum decay hit Earth, you wouldn't feel it. You wouldn't have time to be scared. You wouldn't even know you had died. One moment you are thinking about what to have for dinner. The next moment you and the atoms that make you simply cease to exist. It is the most efficient, painless, and absolute end imaginable. How do we know we are on the edge? It comes down to a cosmic tug of war between two specific particles. We already mentioned the Higgs Boson, which tries to keep the universe stable. But there is a saboteur, the top quark. The top quark is the heaviest elementary particle ever discovered. It interacts strongly with the Higgs field. While the Higgs boson pushes the universe toward stability, the massive top quark drags it toward instability. Physicists have measured both masses precisely. When you plot them on a graph, our universe lands in a very specific narrow strip called the metastability region. If the top quark were slightly heavier, the universe would have collapsed billions of years ago. If it were lighter, we would be perfectly safe. Instead, we are right in the danger zone. We call this state metastability. It doesn't mean the universe is unstable and falling apart right now. It means it is stable, for now. Think of a bottle of supercooled water. You can cool water below freezing and keep it liquid if the water is very pure and still. It looks stable, it acts like a liquid, but it is living on borrowed time. All it takes is a single tap, a single nucleation point, and the whole bottle freezes instantly. Our universe is that bottle of water. We have lasted for 13.8 billion years, but we are waiting for the tap. This leads to a common fear. Could we accidentally tap the bottle? When CERN turned on the Large Hadron Collider, people worry we might trigger vacuum decay. The answer is no. We are not that powerful. Nature is a much bigger particle accelerator than we are. Every second, high-energy cosmic rays from supernovae and black holes slam into Earth's atmosphere. These collisions are millions of times more energetic than anything humans can create. If high-energy collisions could trigger vacuum decay, the universe would have destroyed itself billions of years ago. We are safe from our own machines. But just because we can't trigger it doesn't mean it hasn't happened. The universe is infinite. Quantum tunneling is a game of probability. Somewhere 1 trillion light years away, a bubble of true vacuum might have nucleated 1 billion years ago. It is expanding at the speed of light, devouring galaxies heading straight for us. It is the ultimate cosmic shark swimming in the dark, and because of the speed of light limit, we will never know it exists until it arrives. However, we have one defense mechanism: cosmic expansion. We know the universe is expanding, and that expansion is accelerating due to dark energy. If a vacuum decay bubble starts far enough away, the space between us and the bubble might stretch faster than the speed of light. The bubble is chasing us at light speed, but the road is lengthening faster than the bubble can run. In this scenario, the bubble will never reach us. Dark energy might be the only thing saving us from the true vacuum. So should you lose sleep over this? Probably not. While the universe is metastable, the probability of a tunneling event happening today is infinitesimally small. The math suggests that the current state of the universe will likely last for $10 for $100 years. That is a Google years. By that time, all the stars will have burned out, all the galaxies will have drifted apart, and even black holes will have evaporated. Vacuum decay is likely the final curtain call for a universe that is already dead. There is even a theory that offers hope. What if vacuum decay isn't the end, but a beginning? Some physicists propose that the true vacuum inside the bubble isn't empty. It might just be a region with different physics. Inside the bubble, the laws of nature are rewritten. Maybe those new laws allow for new types of matter, new stars, and new forms of life that we cannot comprehend. In this view, vacuum decay is how the multiverse reproduces. Our universe is dying to give birth to a new one. In fact, vacuum decay might be necessary. If the universe lasted forever in its current state, weird things would happen due to entropy. Given infinite time, random fluctuations of particles would eventually assemble spontaneously into objects or even fully formed conscious brains known as Boltzmann brains. It is a nightmare scenario, a universe filled with lonely, hallucinating minds floating in the void. Vacuum decay acts as a cosmic cleanup crew. It ensures that the universe ends with dignity before it descends into madness. The most humbling part of this theory is our total lack of agency. We can deflect asteroids. We can stop nuclear war. But we cannot stop the vacuum. We cannot reinforce the Higgs field. We cannot build a shield against the bubble. We are passengers on a train that we cannot steer, traveling on a track we did not build toward a destination we cannot see. But there is a strange comfort in this. If the universe could end at any moment without warning and without pain, then the future is not guaranteed. And if the future is not guaranteed, the present becomes infinitely more valuable. Vacuum decay teaches us that permanence is an illusion. The universe is not a static stage built for us to stand on forever. It is a fragile temporary gift. We are here. We are alive. We are conscious. And for now, the vacuum is holding. So don't worry about the button that might never be pressed. Just enjoy the party while the lights are on.